Okay, so I'm going to do a quick review of trigonometry. We're going to be finding slopes of a variety of functions, including trig functions. This will be a quick review of trigonometry. For some purposes, it's convenient to express angles in degrees, but in the calculus formulas that we'll be working with, it's more convenient to express it in radians. So the trig functions are defined in a couple of different ways. For angles between 0 and 2 pi radians, pi over 2 radians rather, they can be defined as ratios of sides of a right triangle, and so the sine is going to be the side opposite the angle, opposite theta, divided by the hypotenuse, the longer side. The cosine is the adjacent side divided by the hypotenuse. Tangent is the opposite side divided by the adjacent. Cotangent, adjacent divided by opposite. Secant, the hypotenuse divided by the adjacent. The secant is 1 over the cosine. Cosecant is going to be 1 over the sine. The hypotenuse over the opposite. So that's one way of defining the functions. They can also be defined on the unit circle. That is a circle of radius 1. And this sort of expands the angles, so we're not limited to angles between 0 and pi over 2 now. So on the unit circle, the sine, the cosine would be the x-coordinate, and the sine would be the y-coordinate on the unit circle. So they're also defined in that way. So for example, if we want the sine of pi over 2, we go to the unit circle, and the y-coordinate there is 1. So then that means the sine over 2 is equal to, sine of pi over 2 is equal to 1. Secant of pi over 2, well, secant is 1 over the cosine. So if we go to the unit circle to pi over 2, the cosine is 0. So this is going to be 1 over 0, which is undefined. Secant is going to be undefined. Tangent of 3 pi over 4. We go to the angle 3 pi over 4. The angles are measured from the positive x-axis, so in the counterclockwise direction. So 3 pi over 4 is going to be over here. It's called the second quadrant. We see that the x and y coordinates here are the same except for the sine. That the tangent is y divided by x, so these are the same except for the sine, so it's going to be a negative 1. The tangent of 3 pi over 4 will be negative 1. The cotangent of 7 pi over 6, that would be down here. Cotangent would be the x-coordinate divided by the y-coordinate. So we have a negative 1/2 root 3 divided by negative 1/2. The negative 1/2 will cancel, and that will just give us root 3 for the cotangent there. The secant, 13 pi over 6. 13 pi over 6 would be, well, that's more than one's full circle. That's going to be the same as pi over 6. And it's going to be 1 over the cosine. So it's 1 over the x-coordinate. So it's the x-coordinate is root 3 over 2. So it's 1 over root 3 over 2, which would be 2 over root 3. And you can, if you want, you can multiply top and bottom by root 3 to get 2 root 3 over 3 to get the square root out of the denominator. The cosecant of minus pi over 4, so that'd be pi over 4 in the clockwise direction from the positive x-axis. It'd be the same as the same terminal side as 7 pi over 4, so the cosecant is going to be 1 over the sine. So it's 1 over negative root 2 over 2. So it's going to be negative 2 over root 2, which would be negative root 2. Okay. Next example, solve for x. Sine of x is equal to 1/2. Well, we're looking for y coordinate 1/2 here, and we see it's x could be pi over 6 or 5 pi over 6. The y coordinate is 1/2, so it's going to be on the unit circle. So y equal or x equal pi over 6 or x equal 5 pi over 6. But we could also, if we go once around the circle and land at pi over 6, that will give us the same terminal side, the same y coordinate. So we could say plus any multiple of 2 pi plus 2k pi for either one of these for k equals 0, plus or minus 1, plus or minus 2, etc. Okay, so that means that the sine function is not invertible. In fact, none of the trig functions are invertible unless we restrict the domain. And the usual restriction for the sine is the closed interval minus pi over 2 to pi over 2. And if we restrict the domain to that interval, we get only one solution for sine of x is equal to 1/2, and that's going to be pi over 6. So the sine inverse of pi over 6 is equal to 1/2 if we sine inverse of 1/2 rather. Sine inverse of 1/2 is equal to pi over 6. So if we restrict ourselves to that domain, we get only one solution. I think yeah, that concludes this presentation here. Okay. Well, I will say that we'll get it. I'll say a little bit more here. Yeah, so here I've sort of defined trig functions in terms of functions of angles, but they can also be regarded as functions of real numbers, and I'll say a little bit more about that in the next video. And that concludes this presentation.